All right, well, welcome to another PSL demo day. I'm Jason DeBacker. I'm Associate Professor of Economics at the University of South Carolina and President of the PSL Foundation. I'll be giving a demo day today, and I'm going to talk about how to deploy Jupyter Book documentation automatically for your project to keep your documents up to date with the current state of your project. So with that, let me first just start with a little bit of background on the Jupyter Book project. I'm not going to touch so much on how to develop your Jupyter Book documentation. Rather, I'll kind of assume you've developed it and talk about how to deploy it properly. To figure out how to create documents with Jupyter Book, I'd advise you to go to jupyterbook.org. They've got great documentation in a Jupyter Book about how to create Jupyter Books, which are essentially executable books for your project. So if you think about a Jupyter notebook that you might be familiar with, where you can have text and executable code together, Jupyter Book kind of builds off of that and allows you to create longer form documents with multiple chapters or sections of your book. So you can have a long form explanation of your research or of your project that has text interspersed with executable code. And something that's really nice about the Jupyter Book project that extends that functionality of what you've seen in Jupyter Notebook with the text and executable code together is that Jupyter Book has additional functionality for tech code to render equations and symbols. It includes BibTeX to allow you to cite and build reference pages automatically from those citations. It allows links between multiple sections of your document. It wraps in Sphinx documentation. So if you're building like documentation of your API for your project from your doc strings, that can be wrapped into your Jupyter Book. Additionally, Jupyter Book's really nice to share your documentation because you can publish it as a web page by compiling to HTML. You can also share as a PDF file, or for the sections that have executable code, those can be downloaded as Jupyter Notebooks or launched in Google Colab or on Binder. So there's a lot of different ways to share your documentation with Jupyter Book. And it allows a real flexible format to build your documentation in. Let me just say right now in the PSL community, there are 10 projects that are either incubating or catalog projects in the PSL organization that are using Jupyter Book to do their documentation. I'll use as an example one of those, and that is the OGUSA project. So the OGUSA has built its documentation using Jupyter Book. It's a nice example because OGUSA is a relatively complex macroeconomic model. So there's a lot of equations and things like that that are important for the user to understand. And so those are all housed in this documentation. There's also examples of how to have your API documents built from Sphinx, as well as references and some other features of Jupyter Book here. So I'm going to first just kind of scroll around the OGUSA documentation to show you what that looks like.
Jason, can I ask you a question before you jump into that? So just knowing something about the OGUSA project, you know, we started out with like just a README on the main page of the GitHub with just it written in Markdown, and then we'd have an extensive side document PDF that we in LaTeX that had all the mathematical equations and figures, and then we started moving to like a read the docs and Sphinx type documentation that went on a web page, and then we'd have Jupyter notebooks kind of strewn throughout the repository and other folders where we'd work on OGUSA, and then we've kind of settled on Jupyter Book as the best documentation. And I'd love if you can compare and contrast Jupyter Book with some of those other early types of documentations that we did.
That's a great history. And that's something I forgot with OGUSA, why it's such a good example here, because as you mentioned, we started off with essentially at 3 or 4 different types of documentation that were all related to each other, and you kind of needed them all together to really get a full view of the model. We had, as you said, a README with how to contribute and, you know, what is the license and so on of this project. We had a PDF that was built with LaTeX that, you know, derived all of the theory. We had, as you mentioned, Sphinx documents hosted on a Read the Docs website that had the API documentation. And now with Jupyter Book, you're able to wrap all of those together in one document. So we can go through and look at, for example, kind of the model theory here, where we outline the underlying economic equations that OGUSA is built upon. So we have all of that tech code that used to be in our PDF documentation, all here in the Jupyter Book. And so you can see, for example, here, like the budget constraint of the household here in its theoretical derivation. And then we could go, and we've also got what we had in the Read the Docs before, all of the API documentation here. So if I look at household functions, I can see these documents are built from the doc strings in the OGUSA code. So if I look at the documentation for the household.py module, right, that's going to contain the first order conditions that were derived theoretically below. And we have somewhere in here, we've got a consumption function that is exactly that equation we had in the theoretical documentation. And so that's all there. And we've got our contributor guide and things that we used to have just in the README. That's in this book as well. And so you can really wrap up a lot of different forms of documentation that used to, at least for this project, and I think for many others as well, be scattered in different places. Now they can all be housed in one comprehensive guide to your project in the Jupyter Book format, because it does allow for those different ways in which to kind of present your documentation, the Sphinx, the LaTeX, and so on, all there together in one document. It's a really good point, Rick. So Jupyter Book really helpful in kind of consolidating your documentation that you might have used to have spread across multiple sources here all in one. Yeah, so again, we've had a lot of fun building this document here, Rick and I and others who've contributed to this particular Jupyter Book, where we're able to render equations and have links to those equations, links across sections. We have multiple papers that we cite, that we build our theory from, that are compiled in BibTeX and show up in our references. And then something else that's important for open source projects, I think, is to kind of document where's your project being used. And so all of the PSL projects that are using Jupyter Book, and again, there are 10 of those right now, are kind of tracking citations and use cases of the model. And they're using, again, that Jupyter Book engine that has BibTeX built in to build a list of use cases or citations for the model. Okay, so we're building that in here, and that's another section of the Jupyter Book, so you can see where it's being used. I think that's something nice for projects to have and kind of keep track of how they're being used. Right, so again, for building these Jupyter Books, something like this, again, I'd advise you to go to jupyterbook.org to find that documentation about how to build these. You'll want to pay particular attention. White space matters here, and we had, spent some time kind of debugging issues where there's just one extra white space in a line or something, and things didn't render quite as we expected. So, you'll want to pay close attention to that documentation. And then also, just another warning is the Jupyter Book is a relatively new project, so it's still evolving. And so as they change their API, you'll have to just be on top of that and kind of update your project. But again, the benefits far outweigh the costs, in my opinion, of building your docs with Jupyter Book. And so I definitely advise you to check that out. All right, so where I want to start, though, is assume you've got your Jupyter Book documentation. So you've got some source files. With Jupyter Book, those can be Markdown, they can be restructured text files, they can be Jupyter notebooks that are compiled into your Jupyter Book. So you have a number of different file types that are going to be your source files that are compiled into this Jupyter Book. Okay. And once you've got that set up on your local machine and that's compiling fine, and you can view a book like we're viewing here with this OGUSA book on your local machine, I think the next step you want to do is, how do I get this out there to the world where people can see my documentation? All right. And so what I want to step through here are just the couple steps, and this is a pretty simple process, but there's a couple steps that you want to be aware of in order to launch your Jupyter Books properly to a website. I'm going to, in particular, show you how to launch them to GitHub Pages. Okay. I'll go back to the OGUSA repo, and I'll use as an example 2 GitHub actions that are in the OGUSA workflows that are useful for launching these Jupyter Books. All right. So the first thing I recommend is that you have an action that just checks that the documents build. Okay. This is one that we've created for OGUSA and that you could just copy for your purposes. It's a simple YAML file that's essentially going to check out the repository, set up the environment for this particular project, and then once in that environment, it's going to build the documentation. So you see that in building this documentation, we do a few things. One, we make sure Jupyter Book is installed. We make sure another package that's useful for that Sphinx documentation is installed. Then that pip install -e period, that's building our OGUSA package in this case, building the package for our project. And that's going to be helpful because that's going to be imported when we build this book. All right. Then we're just going to navigate to the correct directory where the book files are kept, where the source files are kept, and we'll run the command jb build to build our book. All right. So this GitHub action we're running on every push to a pull request. All right. So every time somebody pushes a commit to their open pull request, it checks that the documents build. All right. So what this action is going to do is it's going to pass as long as your Jupyter Book builds, and it'll fail if there's an error that causes the book not to build. All right. So if you get a warning where, maybe you're missing some reference that is cited or something like that, but your book still builds, this test will pass. So it's not going to fail on just warnings, but it'll fail on errors that cause the book to fail to build. And why this is helpful, this is just helpful so that you make sure that as you continually kind of push those commits to your project, you're not doing anything that breaks that documentation. So to check before you try to publish your book that it actually builds. All right.
Can I ask a question on this, Jason?
Mm-hmm.
The Python version here is 3.7 that it's building on. If you were to change that to 3.8 or 9, do you have to change the Miniconda version as well?
I don't think you have to change that Miniconda version. I think it's going to take this setup action here is going to take the Python version you specify. That is a good question here. We're building on 3.7. As I said earlier, Jupyter Books is an evolving project. So things, with the API are changing. And in this particular, just check that the documentation build. We test, say, the source code of OGUSA against 3.7, 3.8, and 3.9 currently. But to build the docs, we just want to make sure that the docs build in some stable environment. We don't care if they build on 3.7 and 3.9 and 3.8. We just want to make sure the docs build. So here we're just specifying a single version of Python that we know has worked to build the documentation. And you can see also down below in the task that actually builds the Jupyter Book, we're pinning a specific version of this Sphinx contrib bibtech package. And that's because, again, as that Jupyter Book documentation as a Jupyter Book API has evolved, there have been conflicts between these different dependent packages that help build the Jupyter Book for OGUSA. And so we've just pinned that here in this case. We haven't checked recently, to my knowledge, and maybe we can unpin this. Maybe the Sphinx contrib bibtech package is now more up to date with the latest Jupyter Book. But again, in my opinion, it's not a big deal to pin this particular package because all we care about is we just want to, this isn't running our source code. This is just building our documentation. And so here we've pinned that. If you copy this file for your project, you may do things like you might want to change that Python version. You might not use Sphinx, and so you don't need to install this additional package, or you found that the latest version is compatible with your documentation in Jupyter Book, and so you don't need to pin to version 1.00. But those are a couple of things that we're doing here just because, again, we've had issues as we've been developing our project and as that Jupyter project has evolved that we've had conflicts where the book doesn't build. All right, so that's the first step, is add a GitHub action to the main branch of your repository that just checks that the documentation builds. And again, I advise doing this on every push. Certainly something you want to have run at least once before a pull request is merged. Then the second GitHub action you're going to want to add to your workflow is one that actually deploys the documentation to the web, in this case to GitHub Pages. All right. And so for this, OGUSA's GitHub action is shown here. We're building off the GitHub action of James Ives. And he's got this nice GitHub action that deploys your documentation to GitHub Pages. And so what this is doing here is it's going to have code similar to before, where we're going to build that Jupyter book. But then after that, there's another action here that deploys that Jupyter book to GitHub Pages. All right, so you could deploy it to another branch. Again, we like doing it to GitHub Pages, but you could specify a different branch if you wished. And then you're going to just tell the branch you want it to build to, and then the files that you're going to take over. And in this case, what we're going to do is we're going to look for that folder of built files from the Jupyter book. And we're going to essentially, what this action will do is commit the HTML files of the built Jupyter book to that GitHub Pages branch. Okay. So we're doing this only on essentially pushes to the master. So when something is merged into the master branch, that's when this action is triggered, right? So again, we had that check that documentation built. That's happening for every PR and every push to that PR, or every open PR. And then, so that's all along the way. We can see that documentation built. And then once all the checks are passed for that particular PR, it's ready to go and be merged in. Once that merge button is clicked, that's when this action is triggered, and it'll build that documentation. So as you merge in something new to your main branch, your documentation will be updated at that same time. That's what this action's doing.
So I had a question about this earlier this week, Jason, about in setting this up, it seems like there are some preliminary steps that need to be done. One, there needs to be this GH-pages branch in your repository for this to be pushed to. And two, you need to have a GitHub Pages site enabled in the repository, or some site for this book to deploy. Where does that happen, either before this GitHub action or inside of this GitHub action?
Yeah, great question, Rick. So in this GitHub action here, this deploy action, this is actually going to, if you don't have a GH Pages branch, it will create one for you. So that'll
be inside of the James Ives
that's right.
thing?
Yeah, that's inside this deploy action that we're using, that was created by James Ives. So that's going to create that GitHub GH Pages branch, and again, commit all the files you specify. So you'll pass the directory of files that'll be committed. Those will be committed to that GH Pages branch. And so once this action is run, all of those all of those built files, compiled files for your Jupyter book will be pushed to that and committed to that GitHub Pages branch in your repository. So even if you don't have that GH Pages branch created, this will create it for you. So essentially, kind of to take this particular action here that we're using in OGSA and update it for your repository, just a few things you need to change: name of your repository, name of your environment, maybe the Python version, and then maybe the path to where your book files are kept and where that book will be built from. And then again, the path to where those compiled documents will be. So just updating, 4 or 5 different places in this action can make it work for your project. So once you've run this, GH Pages is created, and you'll have a URL that looks like this, where it's the name of your GitHub organization, .github.io/name of your project. You're going to have a website built. You're going to have your HTML files up there, and you can start to navigate to them. Now, without anything else, they're going to look poor. They're not going to be well formatted. They're not going to have a nice sidebar like this. If you had a logo for your book, it's not going to be there. Basically, the formatting won't be there. So there's one more step you need to do after adding those 2 GitHub actions. And that step is just to commit a file to your GitHub Pages branch. So I try to go to a file that's not on the GitHub Pages branch. Let me just go back to my code here and switch to the GH Pages branch for OGUSA. So you'll see what's pushed here was all that content from the HTML folder. So this is everything we needed to build our document. So all these HTML files, those are pushed with that GitHub action that we just looked at to deploy your docs. The one additional thing you'll need to add to that repo to have them render properly is an empty file. So this is a completely empty file that you'll commit to the main directory in your GH Pages branch that is just given the name .nojekyll. And what that means is essentially that your GitHub Pages is not going to look for any particular theme. And so it's going to then render with that Jupyter Book kind of theme or formatting that you would see if you built your Jupyter Book locally, right? And then once you add that, that's when you're going to get your GitHub Pages hosted documentation to render and look just like that Jupyter Book as you built it on your machine. All right, so kind of again, to review the steps here, after you've got your Jupyter Book source documents in some directory on your main branch of your repository, you want to add a couple GitHub actions to that main branch. Again, I recommend those two, one to check the documents that they build, and then another to deploy the documents, okay? You only need to deploy those probably on a merge to your main branch. And so I would specify that in that GitHub action. And then once those two workflows are set up, and once they've run and you've deployed the documents at least once, go to that GitHub Pages branch that if you didn't have it before, now it will have been created, and commit a file that's empty and has the file name .nojekyll. And then with that, you can just then navigate to your URL once that nojekyll file is merged into your GH Pages branch, and you're going to have your Jupyter Book documentation rendered just like this. All right. And again, so it should look just like your Jupyter Book compiled on your local machine. The just a few kind of tips or things you want to think about here. One, is as a maintainer of a project, you might think about how you kind of handle when source code is updated. Is there something else that you should request or require of those contributors to also keep that documentation in sync? The nice thing is with kind of this auto deployment, much of that will happen without any work on anyone's part. So for example, if you were using Sphinx to compile your doc strings into that API documentation, then when somebody modifies the source code, presumably they'll update the doc strings accordingly. And once that's done, when this Jupyter Book is redeployed, Sphinx runs again, updates those API documentation. And so when you go to your web-hosted Jupyter Book, all of that API documentation should be kept exactly up to date with the latest state of the model. Now, your project might have things that aren't so automated, like maybe somebody, is having a change to, the household equations in OGUSA, for example. Now, this particular equation here that's rendered, this isn't coming from anywhere in the source code, docstring or otherwise. So this is a separate source file for the Jupyter Book that would need to be updated. And so you might then, as a project maintainer, think about how you handle that. So if somebody updated the source code to change something in this budget constraint, for example, Rick has an open pull request in OGUSA, and he might think about changing that budget constraint. In his case, what he did is he had a PR already outlining how he's going to change the source code, which necessitated a kind of reformulation of this equation in the theory. And he's already pushed, and we've already merged that pull request into OGUSA. So the theory here is updated. There's an open pull request that'll be merged soon that updates the source code to catch up with this theory. But as a maintainer of a project, you might think how you handle that, keeping your documents up to date with your source code. But Jupyter Book helps automate much of that. Okay, but there'll still be things that you'll want to pay attention to and make sure are kept in sync. But really, that's it. Adding a couple GitHub actions, and then adding to that GH Pages branch the nojekyll file so that you get proper rendering of your Jupyter Book. And with that, you've got automatic deployment to the web of your Jupyter Book documentation. And from there are settings in your GitHub Pages. If you go to your settings on your GitHub repo, not sure I'm logged in over here, but if we were going to go to settings of a project, what we can find is that there's a GitHub Pages tab now. This is new. It used to be under a different menu option, but there's a GH Pages tab there that then you can change some things, like if you want to have a custom URL, you can do that. So some projects in PSL have like custom URLs. So the cost of capital calculator, for example. We can get that to that documentation at, oops, maybe we can. Uh-oh. All right.
Hey, Jason.
Yeah.
I think it's pslmodels.org, not PSL model.
Oh, sorry.
There's a typo.
Yeah. There we go. Yeah, so here's a project. Should have an easier URL for me to remember, but I had a typo there. But yeah, so cost of capital calculator has also Jupyter Book documentation. Here we're hosting at a custom URL, so it's not at the pslmodels.github.io. Rather, it's just at ccc.pslmodels.org. So you can redirect to custom URLs your GitHub pages, so you can have your documentation hosted at a more concise or memorable URL as well. So that's another thing that you might consider doing with your project documentation. All right, guys. Any other questions from those here on the call? All right, guys. Well, thanks for bearing with me.
Let me throw one thing in there, Jason. So you talked about the version control for the documentation being in the same repository. I think that's super nice. One other thing that's kind of slick about these is the figures in the documentation of the text can be created from code. You can actually hide and list the actual code to create the figures right in the documentation, which I think is such a cool feature of the Jupyter Books.
Yeah, that is another nice feature. So your figures as well as tables, you can use executable code to create those, which is really neat if you think about kind of keeping your project up to date. So maybe you had, some plot in your documentation to show a particular outcome of your model or something like that. And then as you update your model, maybe you have additional data or something changes with how the model works. And so that figure needs to be updated. That can be automatically done in your Jupyter Book if you built that figure with executable code in your Jupyter Book. So I agree that is another neat feature. And there's, again, a lot in the Jupyter Book, and I definitely encourage you to kind of peruse their documentation to see all that's available. But definitely a lot of nice features to keep your model and its documentation up to date and in sync with each other. Really cool. And then, yeah, following those steps I kind of outlined today, you keep the deployment of your docs up to date. So it's not just your documentation files, but that public documentation hosted on the web that's up to date with your source code. And kind of as you mentioned, Rick, with the version control, yeah, so that's one reason that it's really nice, or one reason with your book why you'll only want to keep those source files, the markdown, the restructured text files in your main branch of your repository, because all of those are going to be version controlled. You'll have all your changes, the whole history of the changes, the source code. You don't want to check into your main branch the built HTML files. That's going to be hard to version control. It's going to add bloat to your project that's unnecessary. Rather, this workflow where you deploy those built files to the JH Pages branch, keeps that main branch really clean and keeps everything in that main branch under kind of real clear version control. So you can see how those documents changed as you kind of look through the history of the project much more easily. That's a couple good points there. All right, guys. Well, hey, thanks so much for tuning in today, and we'll be back in a few weeks with another demo day.